friends, welcome to the channel. Hope you all are safe and sound with your family. So today we are going to discuss the another topic of numerical methods. What is that? Solution to systems of nonlinear equations by the general iteration method. A similar kind of topic we have covered with the Newton-Raphson method. Okay, that is also a very important topic. If you have not watched that, please go and watch that topic because it is very important. Okay, and a prerequisite for this topic to be covered is what? Is to have a basic knowledge of general iterative method. If you don't know what is the general iterative method, I have prepared a separate video for that topic also. You can go and watch there. That link has been given in description box as well as in I button. You can go and watch. Okay, so let's start our topic. According to the topic, what it says that it gives the solution for nonlinear equations. Okay, so here we will have a similar kind of solution whatever we have done for Newton-Raphson method for nonlinear system. There also we have done the similar solution for nonlinear equations with multivariables. Okay, so we are going to have the same kind of solution here also, multivariables. Okay, before this we have done for a single variable solution. What is that? In terms of f of x. Okay, so now we have equation in terms of x, y, z or many more. There may be multiple variables. Okay, so for the beginning what we are taking two nonlinear equations in two unknown. Okay, so I am taking two unknown. What is my two unknown? That is x and y. Clear? So suppose this is my two unknown. So for two unknown, what I have? I want two equations. Okay, so suppose that two equations are f and g. Clear? So now we are going to have the solution with the help of this general iteration method. So what is the procedure for general iteration method? That we have to convert this equation to a required format. What is that required format? For f function it will be x equals to some function in terms of xy. Okay, similarly for y equals to some function in terms of xy. What we have to do? We have to convert this equation whatever is given into this format. Okay, we have to convert into this format. Similarly for y also you have to convert the second function into this format. Okay, how to do that? What is that? We have thoroughly covered in general iterative method topic. Please go and watch. Okay, so here this is the function given and this is the required format in which we have to go for the solution, right? So before going to the solution, a must condition is what? That you have to check for this condition. If this gets satisfied for particular value of x naught and y naught, that is the first approximation of root, then only we can go for the next solution. Otherwise the answer will not be the correct answer. Okay, so first of all we have to check this condition. This is the must condition, right? Now what will be my next solution? If these get satisfied, after that what we have to do? We have to do for the iteration process. What is that iteration process? A similar kind of iteration whatever we do in a general iterative method. Here also we have to do the same thing but for two variables. So we have to work on two equations. Okay, so first of all what we will do? We have assumed an x naught and y naught for as a first approximation root. So by taking the value we can go for the first iteration, that is x1 and y1. So simply we have to put the value of x naught y naught in this equation. Okay, and after that similar process for x2 second iteration, we have to put the value of x1 y1. Okay, and then we will get whatever value is coming, that is the value of second iteration. Then similar process by taking the value of x2 y2, we will get the value of third iteration and so on. Okay, so here we can define a generalized equation for this method in terms of two variable or two unknowns. Okay, so let's have a clear look. What is this? What is going on actually by taking an numerical example? So this is my problem. What is this? Find the real root of the equation. What are that equations? You can see here. Okay, so here you can see in the equation we are using two variables x and y. That means this is the solution of nonlinear equations by multivariables. So we can use either Newton-Raphson method or this general iterative method. Okay, nothing has been given here and we are going to have the look on general iterative method. So I am going to use that solution for here. Okay, so here first of all what we have to do for general iterative method? We have to convert this equation into a required format. What is my required format? That is x equals to f of x and y equals to g of y. Okay, so here you can see a similar format has already been given, right? X equals to f of x. What is my f of x? This is my f of x. Okay, and y equals to g of y. What is my g of y? This is my g of y. Clear? So we have to work on this two equation. Okay, so how we will do? Here, this is my f of x, this is my g of x. So first we have to go for check of this condition. So here for that I am taking a simple differential of all the functions with respect to x and y. Okay, so here by solving this we got these equations, and now suppose the initial approximation value of the root is 0 0. How we can take it? You can take it randomly. Okay, I have started with 0 0. You can start with 1 1 also. However, you can go with any value. There is no problem. Completely no problem. Okay, so I have started with the value of x naught y naught as 0 0. So by putting this value 0 0 value into these equations to check for this condition, by putting this value here, simply we got the value as 0 for first equation, 0 for second equation also. Okay, so what is that? It is satisfying the required condition. What is that? The value should be less than 1, right? That means we can go for the further solution. If it is not less than 1, then we cannot go for the further solution. If we are still going, that means we are not getting the correct answer. Okay, so what is the next solution? Here, after getting the satisfied answer for the condition, now we can solve for x1 and y1 by taking the value of x naught y naught in the equation f and g. Okay, so whatever value will come, that is my first iteration value, that is the x1 y1. So simply by putting the value of 0 0 in the equation, we got this value, that is for x1 and y1. Okay, similarly we can go for second iteration. Now by taking the value of x1 y1, that will give the value of x2 y2. Okay, so by putting this value, we got this much as x2 and y2. And for next iteration, now we have to take the value of x2 y2 for calculation of x3 y3. So this comes as this. Clear? So similarly we can go for many iteration, and up till how much iteration we have to go? Until we get the required answer. Okay, so here you can see there is a difference between this value and this value. That first value is 0.97, second value is 0.98. That equal, but we cannot stop here. Again, you can have a look on this y3 value and y4 value. There is a much difference. Okay, that means it is clearly indicating that we have to go for further iteration. Okay, so we can check the values in next iterations. I have taken the direct values. You can check the answer by taking the simple solutions as we have done for previous 4 iteration. So I got this value for my as my 5th iteration, 6th iteration, 7th iteration, 8th iteration, and so on. Okay, so here you can see that in 9th iteration and in 10th iteration, for x value the values are almost equal, that is 0.999, 0.999. It is equal up to the 3 decimal places, right? But for y value the value is not like that. It is equal for only 2 decimal places. Okay, so that means for the correctness of y value we need to go for further iteration. So in 13th and 14th iteration I got the value of x is similar, equal, and for y it is similar up to the 3 digit. Okay, 3 decimal places. So here we can stop our iteration and this value can be taken as the answer, roots of the value of x and y. Okay, so you can see the value is x and y is coming almost nearly equal to 1, and this is the actual root. So we are getting a fine value which is very near to the actual root. Okay, so this is the simplest solution for this topic, but one drawback is that what? It needs a large number of iteration. We need to go up to the 14th iteration for the correctiveness of the answer. Okay, and if we compare this method with the Newton-Raphson method, we got the correct answer in just second iteration or maximum up to third iteration. So this is the difference. Okay, the convergence of Newton-Raphson method is very fast, and if we'll compare that, this method gives the convergence very slow. Clear? So this is the clear cut explanation for this topic. Hope you all get a clear understanding. If you have any kind of doubt, you can write in the comment box and give me a feedback that how the lecture is going on, so that I can work lightly. Okay, thanks for watching. Keep watching the videos. Thank you.